Welcome to Zero Knowledge, a podcast where we explore the latest in blockchain technology and the decentralized web. The show is hosted by me, Anna.
And me, Fredrik. In this episode, we sit down with Danny Ryan from the Ethereum Foundation to talk about Ethereum 2.0. We talk about what it is as well as what's happening with this spec. Today we have Danny Ryan on the show. Super excited to have you. I really want to dig into ETH2 and do a little bit of an update on what's going on. We've had Prismatic Labs on before to talk about it a little bit, and excited to see what's been going on since we had them on, and maybe talk a little bit about more general topics as well. So we have Anna with us as usual.
Hello.
And Danny, welcome to the show.
Great. Thanks for having me. I'm excited to dig into this stuff. I've been putting a lot of work in past 6 months, tightening all the specs. So it's a good time to chat about it.
Fredrik, you know Danny, but I don't really know Danny. So maybe we should start off with a quick intro. Do you want to tell us a little bit about yourself and how you got into this space?
Yes. My name's Danny Ryan. I'm from Baton Rouge, Louisiana. I've actually, until like a week ago, resided in New Orleans. I'm out in Boulder now. I've been following Bitcoin for a long time, maybe made some bad trades early on, and kept my eye on Ethereum. Thought it was super fascinating. The obsession took me, over time. I realized it was the only thing that I could really think about, and the only thing I wanted to work on. I was an independent developer at the time and started getting rid of all my clients and started just following research and contributing online. And probably at the beginning of 2018, I officially started working with the foundation, the Ethereum Foundation, and have been working on proof of stake specs and research. And that rolled into working on the ETH2 stuff when proof of stake and sharding all kind of came together.
Something I'm really curious about is how you came to be in the position that you are now. Because I know a lot of people like John Choi, who we had on the podcast before, kind of started as researcher and then moved into various other roles. Like, what was your path within the foundation? Because you're effectively like a project manager over ETH2, but as a communicator, as this sort of layer that glues a bunch of things together. And in an organization like the EF that doesn't really have managers, like how does that come to be?
Right. So I began to contribute just by like editing stuff online, like contributing to some proof of concept code bases. And John Choi actually hired me to the EF. Finally, he's like, "You're doing all this work, like work with us." I said, "Okay, great." And saw that there was a lot of work to do with the Casper stuff when it was still Casper contract, and started just kind of taking that over naturally as I added some testing frameworks and was enhancing the code base. When that work got deprecated, I did the deep dive on sharding research. And really all throughout this, as I began to work with EF, it became apparent to me that research had at least a little bit of a communication problem, in that people would ask us questions and I would respond. And then I kept getting responses like, "Well, I'm just going to start asking you because you're the only one who responded." So for better or for worse, I think we've greatly upped our communication, especially with respect to all the ETH2 stuff in the past 6 to 12 months. But we have some like heavy hitting, like deep research going on in the EF. And then we have also people that are like deep in the engineering. And I have fascination on both. So I'm often communicating with teams on both sides, and it just emerged that somebody needed to really take on the communication. And so it was very organic. No one said, "Hey, Danny, do this." It's just kind of, it happened. Very excited. It's a lot of fun. I get to talk with incredible, smart people from all over the space and all the different sites, all the different teams and sides of the project. So yeah, it's a good spot to be in my opinion.
So why don't we start off with just providing a little bit of context about what ETH 2.0 or ETH2 really is.
Or Serenity.
Or Serenity. Like, for example, we've seen ETH 1.x as a term thrown around, ETH 2.0. Maybe you can just share for the audience what the difference is exactly and what those two things are.
So I guess start with ETH 1x. ETH 1x is an acknowledgement that we have some work to do on mainnet to keep it alive, keep it stable, keep it viable. In the meantime, while we follow this more radical path of an upgrade and almost rewrite for ETH 2.0. And so the ETH 2.0 is an acknowledgement that Ethereum is awesome. And Ethereum is also like a very early mover in this space. And so there's been a lot to learn and grow and a ton of research that's happened since then. And ETH2 is us taking all of that research and insight and radically re-architecting the system so that we can remain a viable, competitive blockchain in the coming decades.
I've heard that ETH 1.x will eventually kind of become a shard in ETH 2.0. Is that still something that is on the roadmap? Is that?
Yeah, I'd say this is still a research question and also just a question for the community in what we want to see happen here. I think the most palatable solution is to roll ETH 1 into ETH 2 at some point when we reach kind of stability on the ETH 2 front. There's two kind of paths you can imagine. One would be that it becomes a shard on its own. But having an exceptional shard that has its own rules and has all of this like legacy code and client to maintain for the validating nodes and for the people that are operating in general is probably not the best path forward because we'd have legacy maintenance forever, and this stuff might not fit into whatever rent or state storage fee model that appears in 2.0. And so another viable alternative, and kind of my favorite right now, is to actually write an EVM interpreter in WASM, deploy it as a contract, fork the state root of ETH1 into this contract and the Ether balances, and then allow interaction with the existing Ethereum 1 state through this contract that exists on a shard in a stateless way by providing the Merkle witnesses of the state that you're interacting with. This is nice because it allows us to ultimately deprecate maintenance of 1.0. It allows us to roll it in, but kind of still keep it isolated. And due to this stateless nature, it allows us to kind of not have to think about how this integrates into whatever state rent or storage fee model appears in 2.0. So those are the keep 1.0 alive inside of 2.0 options. And then there's, depending on needs and community and also the technical challenges that might arise there, other options, and I'm not currently in favor of these, is just let 1.0 run. But to utilize 2.0 to finalize 1.0, so to essentially allocate a bunch of its security to the new proof of stake system and lower mining rewards over time and just kind of let it operate in perpetuity, or to maybe have the mining rewards on 1.0 be a function of the amount of ETH that is left 1.0 and like have it naturally kind of moonlight that way. I don't love that option because I think we've made some like strong promises about stuff existing. I think there's some augur contracts about like, will we be at Mars by 2060? And I don't really like the notion of just letting it die. But again, it's a mixture of a technical question and a mixture of what the community wants to see happen on this.
So I think we'll maybe get a chance to speak a little bit more about that as our interview continues. But before we jump into, because I think we should actually explain exactly what ETH 2.0 looks like. But before we do that, I would like to hear a little bit of a history of where ETH 2.0 came from, when the first spec was proposed. What did it come out of? I think we touched on it in the sharding episode, but it might be good just to give some backstory here.
Right. So at the beginning of 2018, there were two parallel research and development efforts for upgrades to existing Ethereum mainnet. One was just moving to proof of stake, Casper FFG, the friendly finality gadget, and the other was to add sharding via another enshrined contract called the Sharding Manager contract. Both of these proposals were going to have essentially exceptional, like, enshrined contracts in the existing Ethereum state that managed the complexity of the logic of proof of stake and also managing shards. There was a lot of work done on both of these in speccing and in building out and prototyping. I was working a lot on the Casper FFG front, did a lot of work on that contract, wrote the EIP 1011, which I know Parity was active in implementing and was getting close to becoming a reality. There were some serious limitations on both of these fronts in trying to do this work in the EVM. The most obvious is just kind of the rate limiting, specifically just the amount of stuff you can process in the EVM because it's highly inefficient. Like trying to process signatures and update state roots in the EVM, it was going to limit the amount of shards and it's going to limit the amount of validators that could participate in either of these systems, which ultimately is limiting the scalability and the decentralization of the system by limiting the amount of validators. Probably around May, came to a few realizations. One, we're designing a lot of the same stuff in two places. By having two kind of foundational games in the system for validators, we were doing a lot of the same stuff in two places, and we might have a strange thing where one game actually competes with the other. Like maybe it's like not a lot of maybe it's more viable, more profitable to be a validator in the Sharding Manager contract, and then you don't have a lot of base security in your Casper contract, or vice versa. That plus just hitting roadblocks with the inefficiencies of doing things in the EVM. And I was going to actually have to do a little bit of rework on the Casper stuff and have to throw some of the formal verification work out the window by doing a little bit of a medium major rewrite of the contract. All of that was pointing us to, one, we need to unify these efforts. Two, we need to break out of the EVM, which you could reasonably do these things to 1.0 and not do them inside the EVM. But three, given what we know now, given the research, and given kind of the trajectory and path of these more next generation smart contract, blockchain, application platforms, whatever they are, it was more viable and we were going to get more of what we wanted if we made a more radical decision and architected essentially a new system in parallel to the old system and allow the economics and the community of the old system to seed the new proof of stake sharding ETH2.0.
I would say this question, getting into this, is like you have this conversation in every company, in every software project ever. Should I evolve this, piece of shit code base that I've written over the past 2 years and kind of add on the technical debt and keep working on it to make it the thing that I want it to be? Or should I just, kind of leave that there and rewrite it from scratch?
Yeah.
And no one ever has a good answer to that
Right.
question.
And there's always people on either side. Some people love rewriting code.
Yeah.
Some people hate it. And another important thing is that by pulling it out, so we have a plane in flight. I think people use that analogy all the time for 1.0. Making radical changes to it to upgrade was going to be very difficult and probably cumbersome and time consuming and hard to coordinate. By breaking free and having this system operate in parallel to the existing system, it allows us to move very quickly and unencumbered. So like we can fork and upgrade this new beacon chain, which we can talk about, and the existing shards, and just having a very loose link between the two at the beginning, without having to coordinate everything on the 1.0 in parallel. So it allows us to move much more swiftly to get to where we want to go.
I think that definitely gives us a nice basis to dive into ETH 2.0. Even though there's no visuals, it would be really great if you could just describe the sort of major parts of this architecture and maybe tell us what they do.
Right. And I will do my best. Usually in person, I'm like, this thing's over here, and I'm using my hands and gesticulating a lot. So this is an exercise for me. Okay. So we have the existing Ethereum chain. We have a community, we have contracts deployed, we have Ether, we have kind of this foundational economic system. This is to seed a new proof of stake chain that lives and exists in parallel to this 1.0 proof of work chain. So in this new system, best to think of the 1.0 chain as kind of the economic seeds, like where the foundational economics are coming from. So in 1.0, we have a deposit contract where I am sending Ether into this contract. It's essentially a burn on there. I cannot get it back out on the 1.0 from this contract. It emits a receipt with proof of this and some information about me as a validator. And that will then allow me to enter into the beacon chain. The beacon chain is the core system level chain of Ethereum 2.0. It is where the validators exist. It is where their rewards and penalties happen. It is where they finalize blocks. It is where they bring in information called crosslinks back from the shards into it and link everything together. It's really, it's where a random number generator happens. It's called the beacon chain because it kind of sits in the middle, and it is a beacon in the sense of a random number beacon. There's probably a lot of other words that would be good descriptors. One kind of visceral is spine, the spine chain. Like it is the center, the spine of the system. I mean, just even calling it the system chain also makes sense in that like it's where the core system level stuff happens. It's not where user accounts live. It's not where state execution and contracts live. It doesn't even have a virtual machine. It's more of a state machine. It has like very particular things that it can do and state transitions it can go through.
Is this the equivalent of the Polkadot relay chain?
If you're, comparing the two, that's
that.
And it's really, in these proof of stake systems, it is really natural to have this place where validators are congregating and where they're performing their duties and told what to do in their duties. In proof of work, you don't really need this because a lot of this, the random number generator and how you're a participant or not, that's handled extra protocol. It's like I get this piece of hardware and I start all of that complexity that's wrapped up in me getting a piece of hardware and generating all this stuff offline. Like you have to bake into a central place where validators, the participants, not the miners, but the validators, are congregating and doing all of their work. And so again, it's a really natural design decision, I think, to put that into like one isolated component, that then the rest of the system, evolves out of. So beacon chain. So we got proof of work chain to seed the economics of ETH2, the beacon chain, which is the core system level chain.
You mentioned the validators live in the beacon chain, or
yes,
at the beacon chain.
Hang out in the beacon
so
chain.
That's where Casper and POS is happening.
Yes.
Okay.
I mentioned finality, and by when I meant say they finalize things, that's where they do the Casper cycle, where they're voting on recent blocks that they say should be canonical and locked in forever. And when certain thresholds of them do these duties, then they finalize things. And so I think in Casper FFG, you justify something and then you finalize it. And so the core proof of stake algorithm is happening in there. Outside of the beacon chain is these shard chains. Shard chains are very similar to what you'd think of as Ethereum 1.0, but there are a number of them. Our expectation right now in the spec is that there will be 1,024 of them. There's two ways to think about it. The first is kind of like in a tree structure, a hierarchical structure, where the beacon chain sits on top and then it has all these child shard chains as the leaves in the tree. I think that's a nice view. I actually really like thinking of it. This is going to be tough to describe, but I think I can do it. I like thinking of it in a three-dimensional model. So back to that term I used, the spine. Think of the beacon chain as the spine of the system. And the beacon chain as the beacon chain is growing, you have all of these shards as a cylinder kind of around it that are growing in parallel with the beacon chain. Like if you looked at a cross section, it's like looking through a tube. But then the validators of the beacon chain, they're sorted onto these shard chains and pulling back references from the beacon chain, like links back into that spine. And that's creating like this architecture where everything's really like kind of connected together. And the way that these shard chains communicate are through those links back into the center of this body. So that's a visual. I'll go into a little bit of these shard chains. So again, the shard chains have accounts, they have contracts, they have state execution. And the way the validators at any given time on the beacon chain are told which shard chain they need to be validating, which shard chain they need to be building, gathering transactions, building blocks, performing state executions. And at the same time, they're also told a different shard that they're supposed to be cross-linking. And so a cross-link, in that visual, those are those links back in from a shard chain into the core beacon chain. A cross-link happens every epoch, which is approximately every 6 minutes, where validators are in small, what we call committees. They go and they make sure that data is available from the shard chain, the recent data, and they pick a reference, like a recent block, and pull it back in to the beacon chain. And so by doing that, whenever these cross links are made by these committees, it pulls in references from the shard chains and unites the shard chains back into the beacon chain and finalize points of the shard chain. So there's a fork choice rule in the beacon chain, how you find the head of the beacon chain. And the way that you find the head of a shard chain is actually you go into the beacon chain, you find the head of the beacon chain, and then you find the most recent cross link. And then you move into the shard chain at that cross link. It's kind of like the last finalized block from that shard chain, and you walk from there. And so again, everything's comes back into that core system level chain. These cross links actually serve another role. It's the way that the beacon chain gets recent information about a shard chain. And so in that, it's the way that other shard chains get information about each other. And so at the foundation, you have an asynchronous communication model between the shard chains through this cross-linking mechanism into the beacon chain.
I have two questions there. So one is, how many cross links per block can you fit?
This is slightly dynamic based on the number of validators, but once you have 4 million ETH validating, the expectation is that you cross-link every shard every epoch. So I think so an epoch is 64 slots. We haven't talked about slots at all. But 64 blocks can happen in an epoch, and 1024 shards can be cross-linked in an epoch. So I think that's 16 shards are expected to be cross-linked about per slot, although they can be staggered in the sense that you might expect, like optimally, you might cross-link this shard at the next, like at slot 100, but maybe it comes in at 104 because there was some latency issues on getting these attestations. That's another term.
So that also means that you can, like, is cross-linking the main method of cross-chain communication? Or is there some other way? And if it is, like, that means you can have cross-chain communication every, like, 6 minutes, like you said.
The layer one, so stuff enshrined in the protocol, that is how communications happen, is asynchronously through these cross-links. On ETH Research, check out, there's a number of synchronous layer 2 proposals, and our current path forward, at least for the time being, is to only enshrine an asynchronous model into layer 1 and to allow the innovation on the synchronous models happen in layer 2. One of which, a simple one, is it's called an encumbrance, where my ETH, by signing this message, and like, say we have I have my ETH in a encumbrance enabled contract, and you also have an encumbrance enabled contract in another shard. I can sign this encumbrance where this essentially guarantees to you that you have access to this ETH whenever the crosslink does occur. So then you can take that encumbrance and you can now encumber your encumbrance by passing on this other signature. And through that, you can get a synchronous transfers across shards. And there's also a number of synchronous state execution proposals, again, depending on the particulars of the contract and execution model. But due to the complexities really explode when you bake synchronous calls into the layer 1 protocol, in that when you have reorgs on one shard, they might have cascading reorgs across shards. And so all of a sudden you don't really have the isolation and scalability that you expected, and you have people like all sorts of dependencies across this. And so the design currently, again, is asynchronous on layer 1 and innovate on the synchronous in layer 2.
You could also do, like, if you're not actually moving ETH around, you could also do a pure like data layer like whether it's synchronous or asynchronous, like a cross-chain communication layer 2 that only deals with data.
Yeah.
And that would be pretty easy, actually.
Mm-hmm.
So like, as you describe some of this, there's definitely some echoes of other projects. I mentioned the relay chain kind of example. What do you think, like, what are the projects that you think have influenced a lot of this?
I know that Dfinity has influenced Justin's thinking a lot. That was one of the early papers that he read that was like, oh shit, like there's some crazy stuff here. I think the acknowledgement of the need of strong randomness built into that base protocol when they came with using the DKG threshold signatures really, like, I think brought it to the forefront of a lot of projects that's crucial in proof of stake. You know, I definitely keep my eye on Polkadot. I am not super cued into what's going on over there. I probably should be more. But yeah, I think just in general, there's this like emergent space of these next gen blockchains, and they're all definitely influencing each other. I mean, everyone's kind of coalescing on this idea that you bring in BLS aggregate signatures, all of a sudden you can have like way more participants in the protocol doing things. And so there's a lot of synergy being exchanged, and a lot of that's kind of naturally just via conversations and conferences and things.
Is there any, like, do you imagine, I'm just going to use this as an example, but like something like Cosmos, do you imagine Cosmos as influencing this, or would they be used in tandem with this? How do you imagine something like that working together with ETH 2.0? Maybe it's outside of the spec of what you need to think of right now, but like...
Yeah, I mean, the amount with which interoperability is going to influence this, like all of these systems, I think it's interoperability is inevitable. I think it's very important. I'm not going to make a guess as to whether there's going to be thousands of viable chains or tens of thousands of viable chains, or whether it's going to be like 3. It really, I think, is going to shake out in the next handful of years as to what happens there. I mean, if you look at I kind of lean in the direction that there's going to be a power law distribution, and that there's going to be a few like heavy players, and then like tons and tons of little small players. And so interoperability is important.
Something that I think a lot about so I mean, obviously Polkadot, the key goal is interoperability. Like, how do we connect Bitcoin and Zcash and Ethereum and all make them play nice together? With Ethereum 2 specifically, something I think a lot about is like, where does the interoperability live? Like, do we bridge to the beacon chain? What can we get out of that? Like, we can get the crosslinks and we can get messages, but like, if we need to bridge to all of the shards, then we're fucked. Like, that's just not going to happen.
Essentially, I'm not quite sure exactly the interoperability scheme on Polkadot and Cosmos, but we're talking recently about how you can begin to use there's phases. We haven't talked about those, but phase 1 adds the shard chains and just the data, consensus on data. And we're beginning to discuss, how do you actually reasonably use this data, maybe in ETH1 or in somewhere else. And because of the way these crosslinks are formed, and because of the way the state root of the beacon chain is formed, you can actually make proofs about everything on the shard chains via the state root of the beacon chain. And so I kind of alluded to it. We want to use Ethereum 2 to finalize the 1.0 chain in the time being, and to allocate some of the security to the beacon chain. And in doing that, once we do that, we've required 1.0 clients to at least be light clients of the beacon chain. And we can expose at that point the most recent finalized state root to the EVM, to the virtual machine. And in doing that, now the contracts on 1.0 can make claims about data on 2.0 and use like kind of layer 2 state execution of that data. Some interesting things, I think Barry Whitehead is working on this like snark roll up. No, not even the roll up. He's working on an entire snark snarked VM. And in doing that, like he might choose to use consensus on data from ETH2 and have state execution of resolving these starks in the state in a contract on 1.0. And so, again, I'm not too cued into the exact particulars of how Polkadot is doing interop, but that state root might become very important.
Yeah, it sounds pretty reasonable. I mean, the ideal way to do to build a bridge, at least in the Polkadot world, is to have a parachain that is where the runtime of the blockchain is a light client of the other chain. And if you're a light client of the beacon chain and you can get access to proofs of data, then that's basically all you need for interop at that point.
Yeah.
One last thing about sort of the makeup of it. Each shard, are they sort of going to act like unique blockchains? We did this episode on sharding. I know that there's different sort of ways of thinking about it, but do you imagine them ever existing as like micro ecosystems and stuff, or?
Yes, and maybe especially because the path we're taking right now is economic load balancing. So you can imagine a sharded system like this that's automatically doing load balancing on the system level and like moving things around and kind of like keeping that away from the user or whatever the framework the user is using. But again, this brings up kind of massive complexity into your system level stuff. And we've opted for going down a path of economic load balancing, where the idea is if shard 0 is very used and maybe expensive, I move to shard 1. Or if some applications that this contract that I need to deploy exist on shard 7, then I might choose to deploy on shard 7. Granted, there's this mechanism for yanking, where if a contract is enabled to do yanking, you can move contracts around between shards. For example, maybe there's a core token contract, but my tokens with respect to that token contract are their own contract. And because I have ownership over those tokens, I might yank them around between shards. So yes, isolated and in some respect, load balanced through economics. And because of that, you might imagine little microcosms of different activity appear. I can't claim to know what the emergent behavior might be actually on the system. So it'd be very fascinating to maybe analyze year 2 in.
So as I said in the beginning, we talked about this on the podcast like 6-ish months ago, a long time ago. A lot of things that have changed. I think a lot of what's going on in the Twitter sphere and Reddit and everything else right now is like, why do things keep changing? In my opinion, mostly from people that don't know software development and so have no idea how to build software. But that aside, how has the spec evolved? Why has it evolved? And like, how does that happen?
For I guess the first thing is I'll comment on the Twitter conversations. This is only, I think, very recently moving out of a research project. It's been transitioning out of a research project and into an engineering project over the past 6-7 months. We released a feature complete, relatively stable version of the beacon chain portion of the spec that a lot of implementation teams are working towards getting implemented and towards testnets. But that said, the research component of this project and the iterative development of the spec is very strange with respect to many software projects because it's happened entirely out in the open. And so every time we're going down a path where we learn a lot and then end up changing things, this is all very public and under public scrutiny. And Ethereum is very important and very valuable to a lot of people. So obviously there's a lot of conversation that sparks up around that. But to more specifically answer your question, what has changed? And I talked early on in the episode, around May or June, we deprecated a lot of work. The paths towards doing proof of stake and sharding and contracts in the existing EVM. And so that was a radical change. Beyond that, the next couple of months were really like taking many different threads of research and weaving them together into just the basic like structure of a spec, and like proving to ourselves that all of these things that we've been thinking about can come together into a viable system. Then after that, September on till now has been spec writing, taking these research components and like fitting them together into like a sane way for people to implement. And at first there were probably one or two things that came out that then were like almost radically re-architected, although using the same basic components, in cleaner, tighter, more elegant ways. And then there's been iterative design on the spec since then, working through bugs, but also just making things more elegant. Like if we decided to build the spec that came out in October, like it would suck. It would suck in the sense that like it was not elegant. It was not, the components like weren't fitting all nicely together. There were plenty of bugs. Things had terrible names. Like just, we had a lot to think through, and a lot that just was going to take this iterative, design. And we've had a lot of implementation teams working on the spec. Arguably maybe too many at the beginning. So early on, maybe in the fall of last year, it was very valuable to have one or two teams on the bleeding edge, like constantly working through things. But I think we dragged a lot of teams through this process. Now that again, we have this like concrete phase 0, which I will say I'm very proud of. I did not know how much work this was going to take and how long it was going to take when we started. But now we have it. I believe it is good, palatable, elegant, in that now we have all these teams that are working on it have this like very stable target to work towards. And in that, now we're beginning the same process on phase 1, which I mentioned is the consensus on the shard chain data, and phase 2, which is the state execution. So I imagine things are going to be going a lot more smoothly because the implementation and engineering teams have like a very concrete target while we go through this iterative design phase on the other components.
I'm trying to put myself a little bit in your shoes and, trying to come up with, or working to come up with a spec and having a lot of people weighing in publicly. And at the same time, like you need to have this spec developed in order to actually start having it be engineered. So there's some sort of time frame that you need to finish this thing on, and at the same time you're in such a decentralized space. Everyone will have an opinion. Some people will want to join who maybe shouldn't be joining. And I can just picture the kind of challenge that is, because you don't want to be exclusive. You don't want to like tell people that their ideas aren't good. You want to make sure that you're very inclusive, but at the same time, like super fixed decisions need to be made, I imagine.
Yeah.
How do you balance that?
Mild chaos. No, I think it's kind of naturally happened in that the Ethereum research team, the Foundation research team, led by Vitalik, have fostered a lot of these ideas over time on ETH research, which is already kind of this like self-selecting group. If you go in there, like it's very dense. It's very hard to like jump in and just like give an opinion. And so then when we move to specs, like it begins to open it up a little bit more. And so you have more engineers that are weighing in. But then we weren't operating on GitHub at first. We just had this like document that lived. And so it was still kind of isolated. And so we still were able to make like big decisions quickly. And then we moved to GitHub, which is a lot more, naturally kind of collaborative environment. And over time we've had many more teams and many more people weigh in. Again, there's still like kind of a technical barrier of entry in that if you're not very cued into what's going on, it's hard to come in and like give a very strong opinion about something. But the teams that are dedicated and digging into these things have begun to give, especially if we've moved out of research and more into an engineering project, give more and more feedback. And this has been excellent in that, we have our own set of expertise, but every team that comes to the table has a different background, a different set of expertise, and has really like hardened up the protocol and made sure that we're thinking through all these different components. And even now, some of the engineers that are like deep in the weeds on Ethereum 1, because there's constantly stuff to do, we've signaled to a lot of those engineers like, okay, now that we have this stable spec, like please, we've had more insight from them, like kind of battle testing some of the ideas that we've laid in Foundation there. So again, mild chaos, like there's constantly somebody who has an opinion, often great opinions, but it's like a, you know, I think it's naturally, it's been very organic in the sense that we've managed the complexity reasonably and not had too much hangups doing this in the public.
Something that I've struggled with myself in working on this and like within Parity, and something that I don't really think that the public really understands is, on one hand, I kind of want to wait until there's some version of a spec that we can start working from, and I don't want to have like the rug swept under my feet. On the other hand, I know that as soon as I start working on the spec, I'll have useful things to contribute back that will change the spec.
Yeah, absolutely.
So there is this back and forth that needs to happen between the spec writers and the implementers. And that's what you're talking about. Like the teams who are actually starting to build this now are starting to provide feedback. And that's why things are changing. So there's two types of changes. It's sort of like Vitalik dreaming up a new idea and like putting that into the spec. But that's not really what's going on at this stage. At this stage, it's more like, oh, we sent this to the developer and they highlighted that this thing will actually not work because of this reason, and we had to change it. And so the distinction between these two types of changes is something that I don't see anyone really talking about. Like they all just think that, oh, someone is fucking around and changing things all the time.
Right. And I 100% agree, and I think there's been this kind of continuum over the past 6 months as we've been changing from this research component where, Vitalik or Justin or who knows, like dreams up like, oh, we should actually be doing this, and then you have something change. But we have entered into this engineering, like iterative engineering phase where like experts are saying, oh, well, actually, we should probably optimize it this way. Oh, there's a bug here because if you think about it, this corner case, and so things have entered into a different phase. You're right.
Is there any like example from history in other open source communities where something like this to this extent has been undertaken? Because it's quite a large ecosystem already, and there's a lot of people who are well versed. Do you know I don't know my Linux history, but like, is there anything like that?
Yeah, I mean, like Linux is a bad example because Linus decides what goes into it. But no, I don't know. I mean, the general. So on this latter thing that I'm talking about, where like with this, well, not really something we've touched on explicitly, maybe, but bike shedding is a thing that happens everywhere, and it's where like instead of discussing like, you know, where to put up the shed or like how it should work, it's or you're discussing what the paint of the shed should be, which doesn't matter. So like bike shedding happens a lot in software development in general, and especially so in open source. And I can imagine like we've only seen the beginning of bike shedding in ETH2 development. There will be more to come for sure.
Right. I think we've talked about, serialization formats are very important, but we've talked about serialization formats probably more than anything else on the public calls.
That's a typical like bike shedding problem.
That's the paint.
Yeah, maybe it's like the metal framing.
Yeah. And I think this kind of gets me curious on this, like it's like whether it's a research change or an implementation highlight or bike shedding, at what point and who needs to step in and say, hey, like this is enough, we need to stop talking about this is final, we're gonna go with this and let's move on. Like who does that?
Great question. And ultimately, obviously, the EF does have some sort of like leadership position in the community, and can make very strong suggestions. At the end of the day, no one has to do it. And there can be mutiny and people can say, screw you, we're not implementing that version of the protocol. We're going to have red paint instead of black paint. And But that said, there is a strong, like, cohesive drive. People want to see this come to reality. And so at least in the phase 0 component of the specs, like I am becoming more and more resistant to change. And getting some pushback, right? Like some teams are like, no, we should change it all. Like we should keep changing it. We should make it better. Whereas, I'm beginning to err on the side of like, okay, we need to ship. We need to build this thing. And so I think you're going to see a natural tug of war as people come more and more onto the side of stability. But it's going to be not a battle, but like a little mini war.
Skirmish.
Yeah, skirmish, not a war. Wars are bigger than a battle. I don't know. I might exert some of my power on the calls, being like, guys, like we decided this. Let's just be done. But we'll see. No one's in charge, right?
So is there some sort of like ETH 2.0 core dev call? Sort of in the spirit of like what Hudson.
Yes. We do. We had one this morning. It's called the ETH2 implementers calls that I run, and they happen every 2 weeks, very similar to core devs. And we have an increasing overlap between the people on those calls. It's enough of its own effort that we couldn't really have it all in one call. And it's been more of a ragtag group of people kind of experimenting and getting in early on this, and it's becoming more of a formalized thing over time. And I expect, at least for the medium term, for there to be these two calls in parallel because there's so much to do on both efforts. So yeah, they're on Thursdays as opposed to Fridays. They're currently on the same week. So it's today and then tomorrow. Today's Thursday, the 14th. But sometimes they get off depending on, I don't know, scheduling conflicts and stuff.
Is there a Hudson? Are you the Hudson?
I might be the Hudson. As in I run the calls. I think that I'm more deep in the technical weeds of some of this stuff than Hudson is. And so I think I bring a little bit of a different tone in that I'm like explaining a lot of the technical things. But yes, I facilitate kind of the conversation around these calls.
And for a little context to our listeners, Hudson is the person who runs the sort of general Ethereum core dev call. We've also recorded a podcast with him where he talked about how he runs these and some of the challenges that come when you're dealing with a very decentralized space and you're trying to make decisions. Yeah.
And I've learned a ton from watching those calls for years and then being a part of those calls with Hudson. So I think he's a really awesome figure in the space.
I would say that the ETH2 calls and the core dev calls are very different in nature. I mean, it obviously comes from the maturity of the project, but on the core dev calls, it's parity, geth, and some minor client implementers, like one of each. And it's, I don't know, maybe like 15 people-ish. The ETH2 calls are like 40 people.
Whoa.
And the discussion is very different in terms of like the core dev calls is like, what are we going to do about this EIP? What does the community think? It's a lot of this vague discussion about how do we make decisions on what to do? Whereas these two calls are more like, talking concrete, like should the serialization format be little or big endian?
Definitely agreed. In that it's the process is less encumbered by an existing protocol. And that's, again, one of the reasons that we thought it was the most viable strategy to have the ETH2 chain be built in parallel so that we can move rapidly. One, in the efforts around coordinating forks, and two, just in making decisions. Like we can, over time, formalize the process, reintegrating the EIPs or maybe having EIP2s or whatever, and move into the more formal framework. But right now, like, have people who are very into the project, like have people that technically want to weigh in and just kind of like move quick.
You sort of mentioned that early on, or like in the fall, you had a lot of people who were looking to build clients or they're working on this more intensely. How many clients are being built right now?
Somewhere between like 7 and 11. I think it depends on the week. And there are many different levels of sophistication there, and that there's like some like larger funded teams and then some individuals that are experimenting with some hobby projects. There's probably a lot of reasons for this. One is it's very exciting. People are excited to get involved with the future of Ethereum. And two, it's just like, I honestly think that some teams are like, I can make my mark. Like there's a chance here. There's a lot of open space and green field to come in and be like a player in this new system. And so it's drawn a lot of different teams of wide diversity of backgrounds. I think we had a lot of teams come in very early, very excited. And I think I take the blame for that, in that I think I sent a little bit too strong public signaling and being like, let's do it. Let's build this thing. Again, because
anyone can help.
Well, no, and I want all hands on deck. But specifically, I recommended to the EF grants team to put a note in the one of the grants releases, like, we're looking for ETH2.0 implementation teams, and like people really took that to heart, and a lot of teams have shown up. And again, I was probably a little bit eager and a little too early in that signaling, and have dragged people through this like very iterative design process where, I think one team called ETH, I think it's just one guy right now, but he popped in probably like a month ago when things are really starting to stabilize, and like can like just lay the bones there and doesn't have to like worry about reworking the whole thing 3 or 4 times. So again, yeah, lots of teams, lots of excitement. We shall see what becomes viable, what paths forward. The cool thing is, actually, Fredrik and I were talking about this, competition. We're all working towards the same goal, but there's still like this notion of competition between teams, like who's going to get users, who's going to have the viable client first, who's going to build the API that people are going to want to plug into, who's going to build like a really nice validator interface with like backup technology or connect to multiple nodes and all this stuff. Like it's not in the spec. This is all stuff that's like on the outside of the spec that really makes a client unique. Like what language did you pick? What tools are you providing? What interface do you have? And so, yes, there's a lot of communication and coordination effort on having a lot of these teams involved. Like this morning we had our call, and like I was like, okay, today client updates, let's keep them quick because we have a lot of y'all here. But ideally, we see a lot of like competition and a lot of innovation because we have so many people involved.
That's an amazing observation that there's these teams competing in that way. You've gamified it somehow.
Everything's a game.
So it also it was interesting to see Vitalik handing out a couple thousand Ether on Twitter to the various teams.
Oh my god!
It might have helped in bringing in more people to want to participate in that.
I want my airdrop.
Do you think? So I had the question if there's any sort of EIP process for ETH 2.0, but it sounds like it's a little early for something like that. But do you think that could be a way to funnel some of that energy?
Yes, and
Maybe changing it from an EIP to something more exciting where there's prizes. I don't know.
Maybe so. I mean, we have a lot of chance to learn from, take the good and fix the bad from both the technical perspective, but also like the community organization perspective. And so, yes, I think that's going to be a really valuable conversation to have over the next many months, maybe bringing up at some of these magician forums. It's like, okay, this is our current process for EIPs. How might we make this better? How might we re-architect it? I haven't thought about this too much and how you might change the EIP process, and nor am I necessarily advocating for it, because that might just be a can of worms. But there is an opportunity to make some changes here, and we shall
maybe
see.
Instead. I mean, I think I can imagine also like maybe bounties.
Oh yeah, Bounties have actually been really successful for a lot of these client teams already. Gitcoin is super awesome. I'm a huge fan. A lot of teams I know have done some early bounties and actually found like regular contributors, found hires and stuff. I'm super stoked about bounties in the space in general. And I think a really cool thing that a lot of the 2.0 teams have taken to heart is this idea of fostering a community and a repo that enables the community to be engaged. We've seen it like a ton of outside engagement and like just random people popping in. Whereas depending on how you architect your GitHub project or whatever your repo is, you can either like make it really welcoming or you can make it like totally impossible to come in. So I think we've done a really good job there.
So to wrap it up, I think we need to do that at some point, even though it's an interesting topic. I want to talk a little bit about the future, and something that irks me and something that people ask me all the time is like, what's the timeline? When ETH 2.0? And it's such a no one can answer it. No one knows. So I would rather talk like concretely, shorter term future. What do you hope will happen in 2019? Like, what do you hope that we can ship? What process changes would you hope for? Like, what decision making will happen over the next year?
So I fully expect in the next month or two to begin to see viable beacon chain clients targeting certain versions of the spec and communicating first just testnets with their own client, and then second with testnets interoperability and ensure client testnets beginning to be short-lived, and then further down the line having some of these like long-lived testnets where we can battle test things, have some adversaries come in and try to break stuff. I've been following the Cosmos game of stakes. So maybe we'll do something like that where we can have these like medium, like, month-long testnets where we have players come in and try to like collude and break and do some interesting things on the networks. And I'm hesitant to say this, but I'm not hesitant. I'm sure somebody's going to quote me on this, but I expect to launch the beacon chain in 2019. The complexity of phase 1, which is the shard data chains, is not actually that massive on top of the beacon chain. So I don't expect the timing between those two events, the launching of phase 0 and the launching of phase 1, to be too long. And we are beginning to work. I expect the phase 2 spec to certainly be moving towards concrete definitely within 2019. We're moving on a lot of these things in parallel now that the engineering effort has begun on the phase 0 stuff. We're beginning to do the necessary work to put all the state stuff together for phase 2. We're working a lot with the EWASM team now. So again, I expect to see some serious movement this year. I think one thing that's important to note is ETH2. Some people just want to see ETH2 like done. But I think it's important to note that there's a lot to gain at each phase and each iteration. Phase 0 being that we can begin to finalize ETH1, and people might then advocate for reduced issuance, but it seems like the community is very into that kind of thing. With phase 1, with the shard data chains, we can then begin to do all sorts of interesting layer 2 state execution work. There's a lot of interesting ideas on that on ETH Research. I mentioned a few at the beginning of the podcast, how you might actually use the ETH2 data consensus for state execution within ETH1. And then obviously the end goal with state execution in phase 2. But again, like iterative, like we have concrete gains at each of these phases.
Yeah, that was actually a point that I thought we might want to just revisit quickly. When you're talking about this excitement and this energy about ETH 2.0, and a bunch of people jumping in, and it sounds like it's almost like a new generation's coming in trying to make their mark. You still sort of need to, and I know it's not really maybe your group that has to, but in general as an ecosystem, people still have to they have to remember that ETH 1.x is still there, and that there might need to be some, I don't know, some check-in points.
Yes, absolutely. And the dialogue is less and less disparate, and that there's increasingly people that are part of both sides of the conversation. There are people who distinctly are going to put a lot of effort into the 1x or 2.0 or vice versa. But these things are not happening entirely in isolation anymore. And unifying the minds on these is definitely a priority, and it's definitely something that's happening more and more. Ideally, anything that happens on the 1x front, especially with respect to storage fees, can inform 2.0. Ideally, like some of the things happening there are directly related to some of the work we're doing in 2.0.
One thing that I think is important and that I've talked about in various places is setting realistic expectations. And like you said, with all the excitement, everyone is asking for this or that, or ETH 1.x is happening. And like you said in the beginning as well, like the problem with 1.x is now it's this package of things that people expect, and not all of it is going to happen, very likely. So I think managing expectations as a whole is pretty difficult, but specifically as we've seen over, the past with 2.0 is, at first it was Casper and proof of stake on the mainnet, and then that was strong. Like we've pushed the what's the expression? Pushed the goalposts or moved the goalposts several times. And yeah, from an outside perspective, it's disappointing and it's like disillusioning when things keep moving. But it's internally, it's not really moving. It's not that we're like just fucking around and pushing things out or like delaying things in terms of like we can't get it done. It's, things are changing and iterating and evolving. So how do you manage expectations in an environment like this where people are looking forward to something and you want to say, yeah, let's ship a beacon chain by 2019, but you can't really, because don't know that it's going to happen.
Don't quote me on that, even though I just said that.
So when it gets there and it doesn't happen, then there's good reasons for it, but it's still like, oh, but you said, and then everyone is like disappointed.
Yeah, I think in general, upping the communication and resources is something that we're definitely interested in doing from the EF side, and that we've been encouraging all the 2.0 clients to do. And not just update, we implemented X, we did Y, but to give a more open dialogue about the process and what's happening. And we attempt to do that obviously with these 2.0 calls, but they're long and they're dense. So providing more resources and just reiterating, like, none of this shit's ever been done. Like, we're making stuff that's never been made before. Like, we're pushing the limits on P2P networking. We're pushing the limits on game theory. We're pushing the limits on economics. Like, it's super, super exciting. And I know that a lot of people have a lot invested, both financially and just kind of like personally and mentally. Like, people are really into this stuff. And so, like, we're doing our best and we're working our asses off, and tons of people in the community are working our asses off. And I encourage you, if you want to be involved, you can, in the sense that, like, go read through a paper that you find interesting and fix correct typos, like work on documentation, work on local community engagement. Like, there's so much to do. Jump in and be a part of it. And as you become more a part of it, you'll be more clued into the reasoning and the reasons and the kind of the realistic nature of building these things.
Cool. Well, I think on that note, we want to say thank you so much for being on the podcast.
Yeah, thanks for having me. I had a blast.
So I guess everyone should keep their eye out on a few sites. What are the sites that people should be looking at to keep up to date on this?
Yeah, it depends on your level of how technically deep you want to get into this stuff. Some of the conversations on the bleeding edge of what might you expect in the phase 2 stuff is happening on ETH research. A lot is happening on the ETH2.0 specs repo. If you are interested in reading the spec, now is actually a really good time. The phase 0 spec, because we've cut like relatively stable releases. Beyond that, again, a lot of the implementation teams are putting out like every 2 weeks or every month updates. So that's a good way to get clued in. And I know specifically a few of the teams are working on some demos and simulations and stuff that you can run on your computer. And I expect over the next 2 to 4 weeks to have a few of those floating around. So follow some of those teams on Twitter, like Lighthouse, Nimbus, Pegasus. Oh man, there's a million. But follow them. They have some cool resources. And again, like get your hands dirty. Like we're excited to have people playing with some of this stuff probably within March.
Very cool. Well, thanks again.
And to our listeners, thanks for listening.
Thanks for listening.